So here's the asphalt supply system, and that's quite a interesting thing of itself. Basically all the binder is trucked in by transports here, as we see, and then it's pumped into these heating tanks, and they get up to, they heat them up to around 300 degrees, somewhere in there. And then there's a pump system here that actually pumps at a certain rate into the plant. And you can kind of see a little bit here, the little green pipe that goes in, actually goes into the back of the drum. And this is all hooked up to the computer in the control shack. And it'll tell you, what the rate is. For instance, in this case, it's a certain amount of tons per hour. This is just a schematic of one of these tanks. And actually, up to this day yet, we still stick the tank, and that we do that at the beginning, at the end of the day, so we know how much asphalt was used during the day. We also can keep track of it with totalizers, with the totalizer that will show up in the computer. And so here's the bottom right is you can see this is where the binder comes in, the hot binder, and it mixes with the hot superheated aggregate and wrap. And that's where all the mixing takes place, maybe about 10-15 feet. And then it's all ready to go and goes out the delivery. This is just something that when you have material that comes to the plant, it comes in gallons, hot gallons, we call it. And so asphalt cement expands when heated. The volume of the asphalt, 300 degrees, is a greater volume than at 60 degrees. So these two schematics I have here in the middle, one is hotter and it's taking up more volume, but it still weighs the same. So we have to when we buy asphalt on these projects, we do it by the ton. And so before the asphalt can be used in the plant, it has to be adjusted to a volume of a standard temperature at 60 degrees Fahrenheit. And actually at 60 degrees Fahrenheit, you can't even, the binder is like, you can't pour it at all. You can hardly stick your finger into it. That's how it is on the road right now. It's stiff. And so that's how we buy it, though, at that particular temperature. So a gallon of that has a certain specific gravity at 60 degrees. And as we'll see, so I've got a little example problem here. For instance, say a transport loaded at 5,000 gallons comes to the site. It's 300 degrees, the temperature. And so how many gallons of AC in the transport based on the standard temperature? And that should say 60 degrees Fahrenheit. So this first thing is you've got your truck over here and it's got 5,000 gallons in. So you're going to want to reduce that down to a standard temperature of 60 degrees. So in other words, the volume is going to go down and the gallons. So actually you go to your pocketbook of useful information, and you can get the correction factor that will bring it down to a certain temperature, reduce the gallons of it in there. So actually this truck now, if it was all cooled down to 60 degrees Fahrenheit, you would only have 4593.5 gallons in it, which isn't a whole lot of difference, but it's enough. Now in B here, we want to know what the tons are. That's what we really, really want to know, because that's how we buy it, is in tons. So the specific gravity we'll just use this as an example. It varies a little bit, but it generally is around 0.030. And so the specific gravity of water is 1, and that's the water is about 8.34 gallons a pounds per gallon. So we just take the 8.34 times 1.03, and that'll give us the actual weight of the binder in a gallon. If you put the binder in a gallon container, it would weigh that much, just a little bit more in water. And so just going through the calculations, that your gallons would actually times the pounds divided by 2,000 would actually give you the 19.6 tons. So that's how much 5,000 hot gallons weighs, 19.6 tons. That's how you figure that out.